Have you ever paused to wonder how scientists figured out that atoms aren't just tiny, unchangeable building blocks of matter? Imagine a time when the very idea of subatomic particles was nothing more than speculation. Today, we're going to unravel the story of the brilliant scientist who changed everything we thought we knew about the atomic world. Yes, we're talking about J.J. Thomson, a man whose discoveries laid the foundation for modern physics. Buckle up, as we dive deep into the life and legacy of one of science's great pioneers. Let's set the scene. It's the late 19th century, a time of great scientific exploration and discovery. The atom, at this point, was considered the smallest indivisible unit of matter. This concept, deeply rooted in the ideas of ancient Greek philosophers and later refined by scientists like John Dalton, was largely accepted. But in the heart of England, at the University of Cambridge, a revolutionary change was brewing. Entered J.J. Thomson, a man whose curiosity and intellect would soon dismantle the old atomic model and introduce a new era of scientific understanding. Joseph John Thomson, known to most as J.J. Thomson, was born on December 18, 1856, in Manchester, England. His father, Joseph Thomson, was a grocer and his mother, Emma Thomson, came from a more affluent background. Despite their modest means, the Thomson family valued education. Young J.J. showed an early aptitude for science and mathematics, a talent that would soon lead him to the hallowed halls of Cambridge University. Thomson began his studies at Trinity College, Cambridge, in 1876. His early academic career was marked by exceptional achievements, culminating in his appointment as a lecturer in mathematics at the Cavendish Laboratory in 1884. It was here that Thomson began his most influential work, diving into the mysteries of cathode rays. At this time, cathode rays were an intriguing phenomenon. They were discovered in the 19th century by scientists experimenting with electric discharges in vacuum tubes. These rays were invisible streams of particles moving from the cathode, negative electrode, to the anode, positive electrode. Scientists knew they existed and could see their effects, but their nature remained a mystery. Thomson was fascinated by these rays. He conducted a series of experiments using a device called a cathode ray tube, a vacuum tube with electrodes at either end. Thomson applied an electric field to the tube and observed the deflection of the rays. He noticed that the rays were deflected by electric and magnetic fields, suggesting that they carried a charge. This was a crucial observation. If cathode rays could be deflected by electric fields, it meant they were composed of charged particles. In 1897, Thomson made a groundbreaking discovery. By measuring the degree of deflection in an electric field, he determined the charge-to-mass ratio of these particles, which we now know as electrons. Thomson's experiments showed that these particles were much smaller than atoms and that they were negatively charged. This was a seismic shift in our understanding of atomic structure. But Thomson didn't just stop at discovering the electron. He proposed a new model of the atom to explain his findings, the plum pudding model. Imagine an English plum pudding, a popular dessert at the time, with plums scattered throughout. Thomson suggested that the atom resembled this pudding, with negatively charged electrons embedded within a positively charged pudding, or matrix. This model was revolutionary because it introduced the concept that atoms were not indivisible but were composed of smaller particles. Although later experiments would reveal limitations in the plum pudding model, it was an essential step in the development of atomic theory. Thomson's discovery of the electron was monumental. It not only altered our understanding of atomic structure but also opened up new avenues of research in physics and chemistry. Thomson's work laid the foundation for the field of quantum mechanics and inspired a generation of scientists to explore the atom's inner workings. Thomson's contributions didn't go unnoticed. In 1906, he was awarded the Nobel Prize in Physics for his work on the conduction of electricity in gases. This recognition was a testament to his impact on the scientific community and his role in advancing our knowledge of atomic particles. But Thomson's influence extended beyond his own research. He was a mentor to many influential physicists, including his own son, George Paget Thomson. George followed in his father's footsteps, studying the wave properties of electrons and winning a Nobel Prize in Physics in 1937. It's a remarkable legacy, showcasing the profound impact Thomson had on the field of physics. Thomson's legacy didn't end with his discoveries. His work helped shape the direction of 20th century physics. For instance, his electron discovery was crucial for the development of quantum mechanics and our understanding of atomic and molecular structure. Thomson's influence is evident in the work of subsequent physicists like Ernest Rutherford, who later refined the atomic model and discovered the atomic nucleus. In addition to his scientific contributions, Thomson was also an esteemed educator and a dedicated mentor. He held various academic positions throughout his career, including the prestigious role of Cavendish Professor of Experimental Physics at Cambridge. His commitment to teaching and mentoring played a significant role in shaping the careers of many young scientists. Thomson retired in 1918 but continued to be an active figure in the scientific community until his passing on August 30, 1940. His career spanned over 6 decades of scientific advancement, and his work continues to inspire and influence modern science. So, when we think about the atom today, we owe a great deal to J.J. Thomson. His discovery of the electron and the subsequent development of the plum pudding model were pivotal in the evolution of atomic theory. Thomson's work paved the way for future discoveries and reshaped our understanding of the microscopic world. To sum up, J.J. Thomson was more than just a scientist. He was a trailblazer who redefined the fundamental building blocks of matter. His discoveries have had a lasting impact on the field of physics and our understanding of the universe. From the plum pudding model to the discovery of the electron, Thomson's contributions have left an indelible mark on the world of science. Thanks for watching, and until next time.